Welcome, everyone. My name is Dawn Mullally, CPAESS Communication Manager, and we are delighted to have you attend the CPAESS Discovery Seminar Series. CPAESS scientists do everything from explore our ocean depths, to fly into hurricanes taking critical measurements, to our heliophysicists modeling coronal mass ejections, and to those who unravel the mysteries of the Arctic. And we want to share all of this with the public, the UCAR-NCAR community, and our many colleagues at universities and agencies across the globe. Just to orient you all, we are using Slido, which is located below the presentation screen, so that you can post questions to our speaker at any time during the seminar, and they will be answered after the presentation. So today it is my sincere pleasure to introduce you to our speaker, UCAR-CPAESS Associate Scientist, Dr. Murali Rao Malasala, who is an accomplished meteorology and oceanography expert with over 18 years of academic and R&D experience. He is currently working with NOAA NCEP's Environmental Modeling Center. Dr. Malasala specializes in enhancing weather and climate forecasts through advanced downscaling techniques, focusing on model climatology and diagnostic analysis globally. He has published around 50 papers in prestigious journals and continues to develop innovative forecasting products to improve risk management in sectors such as agriculture, health, and water resources. Today, Dr. Malasala joins us to share his most recent work, Hybrid Post-Processing of NOAA NCEP GEFS version 12 Reforecasts for Ensemble Probabilistic Forecasting of Extremes in Summer Maximum Temperature and Rainfall on a Sub-Seasonal Scale. Dr. Malasala, take it away.
Thank you so much for giving this opportunity and introduced to me. I am very much thankful to the team. And today my topic is hybrid post-processing of the NOAA NCEP Global Ensemble Forecast System version 12 reforecast products for the Ensemble Probabilistic forecasting of extremes in summer maximum temperature and rainfall on subseasonal scale. And I am very much thankful to Dr. Vijay Tallapragada to support this study. And also I am very much thankful to NOAA NCEP EMC Ensemble group to creating ensembles and providing the data and supporting the study. And the main motto of this study is, everybody knows the human-induced climate change is not only increasing the global average temperature, also intensifying the extreme weather events like heat wave, cold wave, and cyclone intensity and like that worldwide, and notably affecting so many areas and particularly developed and developing countries. In the recent decades, the global average temperature have risen significantly, particularly in the last 3 decades. When we are compared since 1850, the 3 decades, it is abnormal increase it is there in the temperature. The increased temperature is lead to rise the water vapor content in the atmosphere, and it is causing to significantly increase the number and intensity of the heavy precipitation events across the globe, various part of the globe. This is one of the evidence to increase the temperature in the recent period. And the increased extreme weather events like cold wave, heat wave, and floods, droughts, those have the serious societal, agriculture, and economic and ecological impact across the globe. And for one of the example, Taiwan, the temperature increase in the last century. It is a double to the when you are compared the entire northern hemisphere. Entire northern hemisphere, it is average increase. It is 0.7 degrees centigrade. But in Taiwan, the small island itself, it is 1.4 degrees centigrade. It is there. That is one of the example. And also one more example, you can see the extreme rainfall events since 1980 in the United States have the lead to property loss, surprising almost 0.75 trillion US dollars. It is already found in the one study. And the increase of this heat wave or cold wave or rainfall, weather and climate extremes on a rainfall and temperature on subseasonal scale, particularly it is the challenging task for the meteorologist when compared with the short range and medium range and seasonal outlook, because the subseasonal scale due to the loss of the initial atmospheric conditions memory, and that will be impact a lot on the forecast accuracy. So that's why it is the subseasonal scale the more challenging. The accurate predictions on this time scale, but the accurate predictions on this time scale, it is very much helpful in the tactical decisions to strategic decisions made by based on the seasonal forecast, and also help in the timely reviewing of the prevailing seasonal conditions. And in the recent means in September 2020, NOAA NCEP has implemented global ensemble forecast system version 12 model to support to the stakeholders for the subseasonal forecast and hydrometeorological applications. And the consistent reforecast data of this model, it is available since 2000 to 2019. And this data is initialized at every day 00 it is initial conditions, and with up to 16 days forecast, it is available five ensemble members except on Wednesdays when the forecast is integrated up to 35 days and with 11 members. It is well known any raw model product, it is not rarely used in the operational. It is need to some post processing methods, particularly for the unsubseasonal scale, because the skill is low and everybody knows that. So the suitable statistical post processing techniques highly required for the skillful forecast guidance and to increase the usability of the products. So in this present study, we have proposed the hybrid post processing method that combine the artificial neural network deep learning with the Quantile-Mapping technique to enhance the subseasonal predictions of the temperature and rainfall using GEFS version 12 raw model data. And particularly this method is applied various regions. In this present study, I have shown one of the region Taiwan, and another one is the continental United States for the rainfall and temperature case. Also, this method effectiveness is evaluated against the method alone and AN and deep learning method alone in diverse regions. For example, Taiwan and Kansas region. The data and methodology used in the study, the model data is from the available 2000 to 2019. And this model data basically from day 1 to day 10, it is available for the quarter degree. And later on day 11 to day 35, it is available for the half degree data. And this entire data for the consistency purpose, we have interpolated for the half degree for the day 1 to day 35. And here I have used both 5 members case every day 00 it is initial conditions also used for the Taiwan case to study the week 1 and week 2. And in case of the Kansas region, I have used for the weekly ones initial conditions from the day 1 to day 35. Particularly, we want to see improve the forecast for the week 3 to 4 and monthly scale. So that's why weekly ones initial conditions I have used in that case. And in Taiwan case, I have done the study for that maximum temperature case to how the model is performing and how much it is improving the applied calibration method to predict the heat waves for the Taiwan region. In this case, I have used it for the reference data set for the ERA 5 Tmax. I have used it for the Taiwan. In Kansas region case, I have used CPC. In the Kansas region, continental United States case, I have done the study for the rainfall and also maximum temperature and minimum temperature. Rainfall and temperature, maximum temperature, I have considered for the summer season, and I want to see the cold event case. That's why I have considered for the minimum temperature case winter season, December, January, February. So in this study, I have basically applied 3 calibration methods. One is the Quantile-Mapping method, and another one is the artificial neural network deep learning method. And the combination of the artificial neural network and Quantile-Mapping method, 3 methods I have applied in this study for on the three parameters in both the regions. And this Quantile-Mapping technique, it is basically mainly used to correct the model predicted variable distribution mapping onto the observed variable distribution. Like if it is the rainfall you are taking, mapping onto the observed rainfall, and the minimum temperature you are taking, minimum temperature, like that. Also, this process is called as the histogram equilibration or the rank matching method. Suppose we know the CDF of the observation and model, then we can calculate using the inverse CDF of the observation and CDF of the model, and the particular day forecast we can correct by using this formula. And this Quantile-Mapping method I have applied in the leave-one-out cross-validation mode. And the second method is the artificial neural network. The artificial neural network mainly inspired by the human brain are great at handling the complex data. They use intricate structures with the many layers to find the important patterns in the information. ANN technique are good at doing the different jobs like grouping the data and sorting the into the categories and making predictions and forecasting time series patterns because they can adapt to use the connected nodes and process information. The ANN algorithm does match to add up input each node, and each node has adjustable the weights and biases that get to the tweak during the training to make predictions more accurate by reducing the errors. Among the ANN architecture, the FNN feed-forward network is a standout as one of the simplest. Data flows unidirectionally from the input layer through the ideal layers until the reaching out the output node, facilitating efficient information process. And one more important thing in the artificial neural network, the activation function is important. The activation function allows for the changes in the input data that are not just straight line, but this make the model capable of the learning and doing more complex tasks accurately. And one more important thing, the loss function also it is very much important. What loss function you are using, based on that also the output predictions output scale it will be depend on that also. Most of the times you are using mean square error in my study. This is the I have considered for the two regions. In the Taiwan case, I have considered for the everyday 00 UTC initial conditions with 5 members up to 16 days forecast. So here after lot of exercise, I have considered for the one single ideal layer in the temperature case, and the neurons in the ideal layer I have considered 7. How I have found? I have increased the number of neurons, want to like that increase. Here I have considered particularly 70% of the data for the training and 30% of data for the validation. When I am observing, when I am increasing the number of neurons in the hidden layer, in the training period and validation period, the skill is improving. But after certain number, up to 7, when I am going to the up to 7, it is increasing both. But after 7, when I am going to the 8 or 9, something like that, the training period skill is improving, but the skill is deteriorating for the validation period. So that is the 7 is the optimum. I have selected like that. So this tabular form, I have considered the following criteria consider for the developing a model, like one ideal layer and 7 neurons, and 70% data randomly I have selected for the training and 30% for validation. Once model is developed, I have used that model to generate the entire period data. And particularly in this case, I have used it for the sigmoid function, and I have used loss function mean square error I have used. And this is the flow chart of the methodology used in this study. You can see first I have obtained the data from the GFS version 12 and error 5. Then after that I have pre-processing in the same grid point 0.5 by 0.5. And here I have used actually 31 days moving window. Suppose I want to predict for the June 1st. In Taiwan case, I have considered for the summer, June, July, August, September. Suppose I want to predict for the June 1st. Then I have considered for the 15 days and the reforecast data 15 days before and 15 days later. In the middle, the June 1st, I have considered like prediction time, and I have keeping the withhold. Like 20 years data for the this 30 days, almost 620 time steps it is using for the developing the model for training and validation. Like that, once I have developed the model, I have predicted to the June 1st. Like that, I have entire from the June 1st to June September 30th. I have followed the same way for the 20 years. For the 20 years, the withheld means the particular year, particular which day we are predicting, that day only we are keeping the withheld. Remaining all the data set we have used. So here it is the raw product we have considered separately, and after we are applying for the Quantile-Mapping method and ANN deep learning method in this way. Once I am getting the ANN output, again I'm applying for the Quantile-Mapping method on the ANN output to improve the distribution. Particularly, most of the ANN, because it is based on the what loss function we are used, based on that it will there. We are using the mean square error. It is mainly working towards the mean and to reduce the error. So it is smooth out the sum of the outliers, which is very important for us for the extremes. So it is need to again correct the distribution. That's why I have applied the Quantile-Mapping method on the NN output. That is called here after mentioned as the hybrid post-processing technique. Here I have total 4 output like raw output and Quantile-Mapping output and NN deep learning output and hybrid method output. These 4 outputs are evaluated against the ERA 5 analysis, ERA 5 analysis for the entire JJS period. For that purpose, I have used standard skill matrix, and also I have used for the some statistical categorical skill scores and ensemble probabilistic skill scores also used, because I have used that five members output what I am getting for the developing the ensemble probabilistic forecast. So in this study, I have also evaluated that ensemble probabilistic forecast also I have evaluated. Some of the preliminary results I can present here in the case study as a Taiwan, what I have shown in the methodology, that one I have used here. And this is are the primary results for the Taiwan case. This is the example. Suppose the left one is the climatological mean and right one is the inter-annual variability. Inter-annual variability is nothing but the standard deviation. We can see the raw model, the first row it is the observation means ERA 5. The second row raw product, and third one is the Quantile-Mapping output, and fourth one is the ANN deep learning output. The bottom one is the hybrid post-processing method output. When we are looking to raw product is able to capture the spatial patterns as similar as depicted in the ERA 5 analysis for all the forecast lead times. However, it is a large warm bias. It is there in the central and southern region for all forecast lead times. While in the northwestern part, it is a slight cold bias. It is there. Overall, it is a large warm bias. It is there. But when you are looking for the Quantile-Mapping method and ANN deep learning and hybrid methods, the bias is mitigated all the methods, and the patterns are very similar to the climatological mean. Particularly, we can see all methods it is good in the for climatological pattern wise. Then when we are going to see for the inter-annual variability, the inter-annual variability it is more in the east coast region of the Taiwan as compared to the west. The similar pattern can be observed for the in the raw product and also all the calibration methods. But when we are looking in the raw model product, the inter-annual variability, it is a large overestimation it is there when compared with the ERA 5. But all the calibration methods, the overestimation are reduced significantly. Remarkably, it is reduced and very similar to the observation. But when we are compared among the methods, slightly ANN, it is the slight underestimation it is there, ANN deep learning method. But slight overestimation it is there in the Quantile-Mapping method, particularly for the longer lead time forecast time. But hybrid method, even all the forecast lead times, it is very similar to the ERA 5, even inter-annual variability, which is the highly important for the our predictions. Inter-annual variability, that is very similarly depicted in the hybrid method. And when we are going to for the RMSE and mean bias, here I am not showing all the spatial plots. Some of them it is showing, but here for the showing for the all the lead times, instead of showing the only picking something, I am showing all the lead times here. You can see here in the raw model have the black one is the raw model and red one is the Quantile-Mapping, and blue is the ANN, and green is the ANN, and blue is the hybrid method. The RMS is low for the shorter lead times, and it is increasing with the lead time. But in the RMS, it is more in the raw model product. It is more than 1.5 degrees centigrade. It is there in all the forecast lead times. It is more for the longer lead time. But all the calibration methods, it is significantly reduce the RMSE. But when we are compared with the QQ method, ANN and hybrid method, It is a more reduction it is there in the RMSE, low RMSE is there for all the forecast lead time. When compared with the Quantile-Mapping method, particularly the improvement can be seen for the longer lead forecasts for the day 16, day 15. And when you are looking for the mean bias, in mean bias case, all the calibration methods mitigate well, remove the warm bias. When in the raw model product, it is there more than 0.5 to 1, it is there, 0.1 for all the forecast lead times. In the case of the correlation coefficient, you can see the correlation coefficient in the Quantile-Mapping method won't change anything in the remains same, because slight difference also it is coming because we are using the leave out cross validation. That's why slight difference it is there, but otherwise it is the similar as the raw model product. But particularly we can yeah, one good thing we can see, the raw model itself, it is good for the day one forecast. It is almost 0.8 correlation it is there, but it is decreasing with the lead time in the raw model. But when we are looking for the hybrid method and deep learning method, the both are increasing a lot. It is almost all the forecast lead time consistent correlation coefficient it is there around 0.8 it is there. Even longer lead time forecast, the correlation is improving for the even day 16, 0.42 it is going to the 0.8, 0.4 improvement it is there. It is a big improvement. And when you are looking for the index of agreement, in the similar improvement can be observed, but in the case of Quantile-Mapping, it is as compared to the raw model products, that improvement can be seen, but not consistent improvement. When we are compared with the hybrid method and AN and deep learning method, is a lot of difference it is there, particularly in the longer lead time forecast. So the AN and hybrid method, it is a lot of improvement, particularly their longer lead time forecast. And this is the sum of plots I am showing to understand the spatial, how it will be there. Even you can see spatially raw model have the large warm bias in the south and eastern parts for all the forecast lead times. And all the calibration methods, it is reduced that RMSE. But the reduction is more in the RMSE, particularly for the ANN case. And hybrid method also very similar, but slightly it is more RMSE it is there. But almost it is similar as compared to the Quantile-Mapping method. Quantile-Mapping method, it is the RMS it is increasing with this, but RMS also it is a large reduction it is there when compared with the raw product. When you are going to see the spatial plot of the index of agreement, the index of agreement for the day one forecast, it is high, and it is decreasing with the lead time. And particularly the RMSE, the index of agreement is low for the central part and eastern part when it is increasing the lead time. But all the calibration methods, it is a lot of improvement there for all forecast lead times. But the consistent improvement and consistent scale for all the forecast lead times can be observed for the ANN and hybrid method. The hybrid method outperformed than the ANN and Quantile-Mapping method. Also, we have seen how the probability PDF, probability distribution, how it will be there in the raw model and observation. Also, how it is corrected in the calibration methods. Here it is depicted. Here the blue color, it is there. The blue color is the raw model product, and black one is the observation, and pink one is the Quantile-Mapping. And you can see this is the blue. Green color is the ANN deep learning, and red one is the hybrid method. You can see all the forecast lead time case. When you are seeing the raw model product, it is the right skewed. It is right skewed. That means warm bias, a large warm bias it is there. It is the cause to the large overestimation of the heat wave days it is there because of the large warm bias, But after calibration, the distribution it is improved a lot. But when you are looking the ANN is more converged to the mean value. So slightly the Quantile-Mapping method, it is better than the ANN deep learning method. But when we are looking for the Quantile-Map, the hybrid method, it is exactly overlapped with the observation. That means it is better than the Quantile-Mapping method. Quantile-Mapping method also it is improved, but it is far better, the hybrid method. So the hybrid method is the outperform than the Quantile-Mapping and ANN method to distribute the PDF probability distribution function of the summer Tmax. And when after that I have considered for the to see the particularly for the extreme rainfall, extreme temperature like heat events. So I have considered the data. I have considered 20 years for the entire JJS period. I have considered 90th percentile as a threshold value. First, I have identified the which days are the more than 90th percentile of the Tmax. So those days, by using those days, making the binary data, then I have used for the contingency table to calculate the some statistical categorical skill scores like accuracy and frequency bias and false alarm rate, success ratio, and thread score, ETS, and hit rate and those skill score. Here I have depicted for the this is the one of the skill score that equitable thread score. Here two types of in the two ways I have calculated. One I have considered for the day-to-day matching, and another one is I have considered for the weekly matching. Weekly means suppose week 1, week 2, week 3. Suppose weekly means it is 7 days case. If it is the observation, it shows 3 days in the suppose some example. Then in the model predicted it shows that 4 days. Then that means hit rate is the 3 and false alarm is the 1 and correct negative 7 minus 4 means 3 and miss is 0. Like that I have calculated the contingency table in the weekly case. In the week 1 to 2 case 14 days when I consider, then I have considered the 14 days case. But this is the left one is the day-to-day matching exactly. But in the both the cases, I have seen day to day how the skill scores it is there, and week 1, week 2, week 1 to 2, how it is there. I have presented here, and you can see in the raw model, the ETS score it is more for the shorter lead time, and it is decreasing with the lead time. And the similar pattern can be observed in the calibration methods also. But when compared with the raw model product, a lot of improvement it is there in the all the calibration methods. But when we are compared with the among the methods in the ANN, it is better than the QQ, and hybrid method is better than the outperformed than the to the ANN and Quantile-Mapping method. The similar way you can observe for the weekly case also. But when we are seeing for the weekly case, we day to day compared to day to day scale, the weekly scale the skill scores are better than this for all the cases. So the consistent skill can be observed for the week 1, week 2 in the hybrid method when we are compared with the other two methods. This is the other skill scores means this plot is the performance diagram, which is depicted to the 4 skill score at a time, like hit rate in the left y-axis it is the hit rate, and left y-axis it is the thread score, and the bottom one is the x-axis it is the success ratio, and the diagonal lines race it is there, that one is the frequency bias. If is the along the diagonal line it is there, that means that is the 1, and we can say the frequency bias exactly 1. That means the model is able to produce same number of events as in the observation, like that. So if it is the all the methods it shows to the bottom left means it is the worst, and top right corner it is the best case, it is the best perfect. And when you are looking to here different methods I have shown, this is the day-to-day matching case, and the right one is the week 1, week 2, week 1 to 2. And you can see here the red one is the raw product, and raw product have the large overestimation it is there. That's why the hit rate is more, because every day, most of the days it shows hit rate. So the large overestimation it is there. The Quantile-Mapping method, it is reduced that overestimation. It is exactly same as the observation, the number of events. Even the reduction is the more reduction it is there in the ANN, but ANN case it is improved the success ratio when compared with the Quantile-Mapping method, but consistent skill it is there for it is among the lead times. But when we are applying for the Quantile-Mapping method, where is the underestimation it is there, that is improved in the hybrid method. You can see the hybrid method is outperformed, and also you can see day 1 to day 16 it is not big difference, it is a consistent skill it is there. In the similar pattern can be observed in the case of the weekly case, week 1, week 2, week 3. The hybrid method is the outperformed, and the raw product is a large overestimation it is there, and it is the underestimation it is there, but even some other skill scores it is improved. So in the both the plots, we can say hybrid method is the outperformed than the ANN and QQ. And I have calculated some probabilistic ensemble skill scores for the probabilistic ensemble forecast. Here I have calculated for the reliability and resolution. Reliability, reliability is ranges from the 0 to 1. 0 means it is the perfect, 1 is the worst case. So here the raw model itself, it is good as compared to 0.15, it is good only. But once we are applying the calibration methods, there's a lot of improvement it is there, a lot of reliability is improved a lot, all calibration methods. But the ANN and Quantile-Mapping method, it is improved more as compared to the Quantile-Mapping method for all forecast lead time. In the resolution case, resolution also 0 to 1. Here highest value is the good and lowest value is the worst. Here 0 is the no scale and 1 is the perfect. So you can see the raw model product have the low resolution, but all the calibration methods, it is improved for the resolution, all the things. But when we are looking for the AN and deep learning and hybrid methods, consistent skill, it is there when compared with the Quantile-Mapping method. It is particularly that hybrid method, it is slightly better than the ANN for all forecast lead times. And one more plot, it is for the ensemble probabilistic forecast. This is for the ROC curve. ROC curve, if it is ROC curve, if it is the this is the diagonal line. Along the diagonal line, it is there. That means the predictions are the as same as the climatological forecast or reference forecast. If it is the below the this diagonal line, that means worse than the reference or climate forecast, climatological forecast. And if it is the more than the it higher side and left side, it is there. That means it is better than the reference forecast or climatological forecast. It is there. Here area under curve also I have calculated for all the forecast lead time. The area under curve, it is particularly it is there for the in the raw model product for case of the day 1, it is 0.74. It is better than the reference forecast. Even it is for the day 15 also it is there 0.65. But when we are going to see for the Quantile-Mapping method, it is improved like 0.81. From 0.74 to 0.81 it is there. But when you are looking for the AN and deep learning, it is 0.83. But in hybrid method, 0.85. The same trend, increasing trend, it is there. Means raw product to Quantile-Mapping, Quantile to AN to hybrid method. Hybrid method in all the cases, it is outperformed in the and it is far better than the reference forecast and also compared to the raw and other forecasts, other calibration methods. And this paper is published in the atmosphere. And one more case study, it is there. I have applied this hybrid post-processing technique for the JJ's rainfall and associated extreme rainfall events for the continental United States. Here I have used it for the, actually I want to improve for the, particularly for the week 3 to 4 and monthly scale. That's why I have considered here weekly ones initial conditions, which is that the forecast is integrated up to 35 days. So with 11 members, it is there. So here input is I have used it for the 11 members. After a lot of exercise, I have selected for the 2 EDL layers. In the 2 EDL layers, I have selected for the sigmoid function. And here what I did, I have chosen for the system after exercising, selecting the optimum number I have selected here. In the similar way, what I have explained in the previous case, in the similar way I have applied also here also. Some of the preliminary results of this case study I can show. This is the spatial distribution of the JJ's rainfall in the week 1. Here I have shown for the week 1, week 2, week 3 to 4 and monthly case. This is the bottom one is the monthly and top one is the week 1. And you can see the raw model product. Here I have used the for the reference data, CMOF precipitation data I have used. And you can see the raw model itself, it is able to capture the spatial pattern. And however, it is the some warm, some dry bias it is there in the warm wet regions and wet bias it is there in the dry regions can be observed slightly, but pattern wise it is good. But it is improved a little bit. It is improved in the Quantile-Mapping, that reduction in the bias in that biases. But ANN it is enhance the bias in the positive direction. And when we are applying for the hybrid method, it is a very similar pattern to the CMOF, but slight underestimation is there, not big. And this is more important thing is it is improvement is can be observed for the hybrid method in the particularly entry annual variability, that is nothing but standard deviation. You can see in the CMOS have the a lot of entry annual variability it is there, while it is underestimation, large underestimation it is there in the raw model product for the particularly week 2, week 3 and monthly scale. Week 1 somehow it is captured, but still it is the underestimation. But the quantile mapping method slightly it is improved, but still large underestimation it is there. The NN it is slightly it is better than the quantile mapping method, and but hybrid method it is outperformed, very similar to the patterns are very similar to the observation. This is the case of the overall skill for the day overall mean bias from the day 1 to day 35. You can see it is most of the lead times it is the overestimation it is there. Sometimes cold dry bias also there, but when we have applied the deep learning method and it is the bias is enhanced more. But after quantile mapping method and hybrid method, the error is less. But hybrid method slight underestimation it is there. But when you are looking for the RMSE case, you can see the RMSE's reduction is can be observed from all the calibration methods. But in the raw model, the shorter lead time, less RMSE, and it is increasing with the lead time. The similar pattern can be observed here also, but the NN and deep learning method is outperformed compared to all the quantile mapping method. In the less RMSE is there. When we are looking to see for the correlation coefficient from the day 1 to day 35, enter the Canas region. The Canas region, the correlation coefficient is 0.8, it is there overall. And when after the behind the week 2, the skill is very near to 0 actually. But the quantile mapping method, it is won't change anything, correlation coefficient. But in the ANN and hybrid method, it is improved a lot. It is almost improving 0 to 0.3, it is increasing. Right? Particularly the improvement, it is there for the longer lead time forecast. The similar improvement can be observed in the case of index of agreement also. But in the case of index of agreement, for all forecast lead times, the hybrid method is outperformed than the ANN. In the case of this is the index of agreement spatial plot. All the plots it is like it is there for the early for the time series. This is the spatial plot for the week 1, week 2, week 3 to 4 and monthly case. The index of agreement particularly it is more for the week 1 and it is reduced for the week 2 and week 3 to 4 it is less. Monthly case it is more because week 1 also it is involved in this monthly case. So when we are compared with among the methods, all the methods improve the index of agreement, but the more improvement can be observed from the hybrid method, even for the week 2, week 3 to 4 also subseasonal scale also you can observe. And I have also plotted for the PDF, but I have not depicted here. The probability of the PDF plot also it is good and it is same as the hybrid method. It is outperformed than as compared to the other calibration methods. It is improved. And there I have considered actually in this study I have considered 3 type of extremes I have considered like wet days and heavy rainfall events and extremely heavy rainfall events. In the wet days case, I have considered for the days greater than 2.5 millimeter per day days. I have considered for the wet days, and greater than 1 centimeter rainfall I have considered for the heavy rainfall, and greater than 5 centimeters I have considered for the extremely heavy rainfall events. I have considered. For those categories, I have calculated separately for the statistical categorical skill scores. This is the for the ETS of the wet days. In the wet days case, the ETS score for the in the raw model itself it is good, but it is decreased to the week 1 to week 2 and week 2 to week 3, and monthly case it is more than the week 2 to week 3 to 4. And when we are seeing for the calibration methods, all the calibration methods it is enhanced, but the enhancement is more for the NN as compared to the QQ method, quantile mapping, but hybrid method is outperformed than the NN, and this even the skill is more for the week 2 and week 3 to 4. And when you are looking for the extreme events, heavy rainfall events, 1 centimeter and 5 centimeters, this is also even ETS for those. And you can see the ETS for the more for the week 1 case, and it is reduced, it is less for the week 2 and more decrease in the week 3 to 4. And monthly case it is more, but the calibration methods it is improved. Quantile-Mapping method slightly it is improved in the both the cases. Heavy rainfall event case also slight improvement. It is not there in the slight improvement, but once we are improving the patterns by using the deep learning method, it's a lot of improvement it is there in the both the cases. And hybrid method in the outperformed, particularly for the heavy rainfall and extremely heavy rainfall events case, improve the ETS and other skill scores also. So this is the depicted some three categories like wet days case and heavy rainfall days and extremely heavy rainfall days. It is there year days, and this is for the performance diagram. You can see this first plot wet days case. The large under overestimation it is there in the raw model product. The top one is the raw model. Here 1, 2, 3 means one is the week 1, 2 is the week 2, 3 means week 3 to 4, 14 days case, and 4 is the monthly case. In the monthly case is the highest skill it is there, because the forecast, when forecast length is increasing, then the skill is increasing. Then after that it is the this skill is more for the week 1, then week 3 to 4, and week 2 is low. And you can see a lot of underestimation, overestimation it is there in the wet days. It is improving the all the calibration methods, reduce the overestimation, but still it is the large overestimation can be observed for the NN and QQ methods. But hybrid method it is improving a lot, but slight underestimation it is there. But more than 90% of the events exactly it is predicted. And when we are going to the in the case of the extreme case, while it is a large overestimation it is there wet days case, but when you are looking heavy rainfall and extremely heavy rainfall case, it is the large underestimation it is there. In the case of extremely heavy rainfall events, it is unable to detect actually. It is you can see it is almost near to the zero. It is there here. But after calibration, it is improving the skill scores. But more improvement can be observed for the hybrid method in the both the cases. The lot of improvement, particularly it is there heavy rainfall events case. And here also I have calculated some ensemble probabilistic skill scores using that 11 members output. Here this is the Breyer score and reliability. Here I have calculated average scale for the week 1, week 2, week 3 to 4, and monthly scale, and reliability also. If Breyer score and reliability, if the low value it is there, that means it is good. If the higher value it is the worst case, worst. So here you can see in the all the cases, this is the case. First top one is the wet days case, and middle one is the heavy rainfall events. Bottom one is the extremely heavy rainfall event case. All the cases, the Breyer score and reliability, it is the hybrid method, and it is lower side. It is there. That means as compared to the hybrid method, it is more lower. Means it is the outperformed than the ANN and Quantile-Mapping method. That hybrid method is outperformed to the ANN and Quantile-Mapping for the ensemble probabilistic skill score of the wet days and heavy rainfall events and extremely heavy rainfall events. This is the case here, because I am not showing that ROC curve graph here. Simply I want to show for the how it is skill it is there for the day 1 to day 35. So I have calculated, I have shown the line graph how it is the skill it is there overall for the wet days and heavy rainfall days and year days. And you can see in all the cases, if it is the more than 0.5 means it is the better than the reference forecast. If it is the equal to 0.5 means it is the same as the reference or climatological forecast. If it is the lower than 0.5, that means the worse than the reference forecast. But in the three cases, all three cases, the skill is more than 0.5 only. Means raw model product is good. But in case of extremely rainfall events, beyond the 2 weeks, it is near to zero. It is almost same as the reference forecast. But in all the calibration methods, those skill scores it is improved. But lot of improvement, particularly can be observed for all the forecast lead time, particularly for the extreme rainfall events from the hybrid method, as compared to the ANN and Quantile-Mapping method. So in this is two cases. Third case also I want to see actually in the hybrid method is outperformed in all the cases. Even this method is working better for the less training period. How the training period is impacting on the hybrid post-processing performance, I want to see that. So that's why I have considered for the three cases, summer rainfall and Tmax and T minimum. T minimum for the winter T minimum I have considered here. Here I have considered for the like 2000 to 2019 total period. In that 2000 to 2019, in 2015 to 2019, I have used it for the predictions. And I have used for the 2000 to 2014, 15 years period, and 2005 to 2014, 10 years period, and 2010 to 2014, 5 years period, and 2012 to 2014, 3 years period. I have considered like a different training period length. In that different training period length, I have used for the 70% for the training and 30% for the validation. I have developed the model. In all the cases developed models, I have used it to predict the 2015 to 2019 for in the three cases, rainfall case and maximum temperature and minimum temperature case. How the training period size it is impact to the hybrid post processing method. Also, I am seeing that the training period length on the other methods also like Quantile-Mapping and ANN method, ANN deep learning method also I have seen, and I have compared the results. Some of the results I have here. This is the hybrid method, and we know already in the previous slide. We know the hybrid method is the outperformed than the all other methods. Here I have seen particularly compared with the raw and how the training period, different training periods, how it is impact. So you can see in the raw model product, I have the large war estimation it is there as compared to the observation, but all the calibration methods it is well in the mitigate the wet bias. It is very near to the observation. Slightly it is a slight war estimation it is there, but it is a lot of reduction it is there for all the forecast lead times. Particularly compared to the climatological mean, particularly the improvement can be observed for the inter-annual variability. We can see the inter-annual variability in the raw model product. It is almost same as the observation for the day one forecast, but day two onwards you can see it is a lot of reduction. It is decreasing the inter-annual variability IAV, while it is but all the calibration methods, even 15 years training period also it is improved, and 3 years training period also it is improved. That means in the training in the hybrid method, the training period length, some sensitivity is there, but it is the impact is very minimal. Very minimal it is there. I can show some of the proofs, and after that, this is only for the only that hybrid method with a different training period. If it the more training it is there, more training period it is there, then the skill is more. When it is the number of years it is decreased, it is decreased, the decrement it is there, but it is a very zooming, but the decrement is very less. In this is the case of CC, and this is the case of the index of agreement. If it is the more data it is there, then it's good. Even if it is not there, even less training period data it is available, the improvement is lot as compared to the raw model product. And this is the case of the 15 years training period and 3 years training period. In case of the extreme heavy rainfall event case, you can see we know the raw model have the large underestimation it is there. We know here it is there. But after applying all the Quantile-Mapping and deep learning method, slight improvement it is there, but not that much. But you can see in the 15 years case, the hybrid method it is along the diagonal line, and it is improving all the skill scores. Even hit rate it is improved, success rate also it is improved, threat score also it is improved. Lot of improvement it is there 15 years. But the similar improvement can be observed, means slightly it is reducing it is there. This is the 3 years training period, and the training period impact is more in the ANN and Quantile-Mapping method. But even when compared with the raw model product, even 3 years training period also it is bringing out lot. The skill is improved lot. But as compared to the 15 years, slightly it is less. But the big improvement it is there. And in the case of this is the ANN and both I have here plotted. Here it is the 15 years, 10 years, and 3 years, and 5 years and 10 years period. Here 1, 2, 3 means 1 is the week 1, 2 means week 2, 3 means week 3 to 4, and 4 is the monthly case. And monthly case is anyway it is high scale in the ANN also. But when we are compared with all the training period case, here different colors, different training periods, all the training periods, it is improved. Lot of improvement it is there as compared to the ANN in the hybrid method. And also a lot of some impact it is there training period length here, but here it is here also there, but the impact is very minimal. This is the case of the summer, that is the rainfall case up to there. This is the case of the summer Tmax. Here Tmax means I have considered for the June, July, August. I have considered, and in this case you can see this is the overall performance, how it is performing with the 15 years training period using for the prediction for the 2015 to 2019. You can see in the mean bias case it is large cold bias it is there. Cold bias it is there over the Canas region in the model, Ra model. It is almost less than -1, more than -1 degree centigrade it is there. When we are applying for the calibration method, Quantile-Mapping method, it is improved. But when compared with the hybrid method and NN method, it is large improvement. It is there even longer lead time forecast, day 35. It is near to the zero actually in the both the cases, NN deep learning and hybrid methods. And the similar improvement can be observed for the RMSE case also. RMS is increasing with the day 1 to day 35. But it is the more than 2 degrees centigrade it is there, RMSE. And day 35 you can see it is 4 degree also it is there. But in all forecast lead times, all the calibration methods it is reduced. But the reduction is particularly more in the NN and hybrid method for the longer lead time forecast. Even in the correlation coefficient can be seen. The correlation coefficient also it is improved a lot from almost more than 0.2 it is improved in the hybrid method and ANN as compared to the Ra model. In the Quantile-Mapping method anyway it won't change, it remains it is same. In case of the index of agreement, in the index of agreement Quantile-Mapping method it is improved, but it is slightly. But while we are seeing for the hybrid and ANN method, lot of improvement it is there. Even day 35, large improvement it is there. The slightly the hybrid method is the outperform than the ANN. This is a case of the extreme rainfall events case, greater than 90th percentile days I have considered. I have seen for the 15 years training period and 3 years training period. You can see in the 15 years and 3 years training period case, all other methods means ANN and QQ have the large difference there in the scale in the 15 years to 3 years. But in the Quantile-Mapping hybrid method, it is almost a similar scale, means difference it is there, but not that impact. Even 3 years also, it is improved a lot. In the 3 years case also, it is bringing to the along the near to the diagonal line. So if it is the more training period it is there, it is best. But even 3 years period also, it is the training period length, it is minimal impact. In fact, it is there minimal. This is the case of this is the two cases. That the earlier one is the only all the methods among all the methods with the 3 years period and 15 years period. This is for all the training periods. I have taken 15 years, 10 years, 3 years, and 5 years and 3 years, and compared with the NN and hybrid method. You can see as compared to the NN hybrid method, it is improved. Also, you can see here different colors means different training periods. If one means week 1, 2 means week 2, 3 means week 3 to 4. 4 means monthly case. Monthly case, it is the high scale. But you can say within the same scale, but with the different training periods, the training period length, it is the impact is more on the deep learning method. But a hybrid method, it is there, but very minimal. Almost consistent scale for all the, it is there. The minimal impact, it is there. This is the case of the cold days. In the cold winter, December, January, February, I have considered. For the year, I have considered less than 10 percentile T minimum values. And I have, first of all, I am seeing here by using the 15 years training period case and prediction for the 2015 to 19. Here you can see the hybrid method is the outperformed for all the forecast lead times, and the improvement can be observed for the even longer lead times also. This is the ETS, Equitable Thread Score. And this is for the performance diagram for the same cold days. You can see this is the left one is the different training periods. This colors, different colors, different training periods. 1, 2, 3 means week 1, week 2, week 3 to 4, and 4 means monthly. And this is the left one is the NN, and right one is the hybrid method. You can see among the same scale with the different training periods, some variability is there, difference it is there, and that means training period impact it is there on the deep learning method, but hybrid method it is very minimal, and when compared with the NN, the skills are it is more in the hybrid method. That is these are the my major findings. Major findings I can here. The GFS version 12 accurately captured the TMAX spatial patterns for the Taiwan, but tend to the overestimation of the variability and the source of warm bias, large warm bias. All calibration methods, particularly hybrid and ANN methods, significantly reduce the RMSE across all forecast lead times. Hybrid and ANN method enhance the correlation coefficient for the Tmax forecast, and a greater improvement for the particularly for the longer lead times. Both hybrid method and ANN method achieve a high index of agreement scores, indicating the better agreement with Tmax predictions. Calibration methods effectively reduce the number of overestimated or predicted extreme Tmax days. With the ANN method showing the most reduction, means slight underestimation it is there when compared with the observation, but hybrid method is same as the observation. So the hybrid method is outperform as compared to the QQ and ANN in all statistical skill scores, and making it more effective for the forecast exchange. The hybrid method is superior, even probabilistic skill score make it highly beneficial for the extended range climate risk management in Taiwan. This is the case of the Taiwan study. This is output some findings for the Canas region rainfall study. The model shows the wet bias in the dry region and dry bias in the wet regions inaccurately represent the in that case like JJ's precipitation variability. Actually, variability it is inaccurate, but all the all the post processing methods correct the bias and improve the interannual variability, particularly the interannual variability from the hybrid method. It is very similar to the uh, observation. And the improvement in the hybrid method particularly can be observed for the week 3 to 4 and monthly scale. The NN method significantly reduced the overestimation of the wet days, improving the both statistical and probabilistic skill scores. But large underestimation it is there when compared to the hybrid method. Hybrid method it is improved both the probabilistic skill scores and also categorical statistical skill scores of the wet days and all other. The hybrid method is provide enhanced prediction accuracy for the high rainfall and extremely high rainfall events, especially on the subseasonal scale. The hybrid method achieve high scores on the categorical metrics like accuracy, frequency, interval, thread score, all skill scores for a particularly improvement for the longer forecast lead times. The hybrid method also good in the ensemble probabilistic skill score, excel, the particularly more beyond the 10 days forecast for the rainfall exchange. Overall, the hybrid method is effective in the improving the subseasonal JJ's precipitation and associated rainfall exchange for the Canas region. And when we are looking for the some sensitivity experiment with the different training periods, the GFS effectively predicts the summer Tmax and the winter T minimum across the Canas, but shows a significant warm bias in the central Canas. Where is the remaining case? It is the cold bias. Inter-annual variability of the Tmax and T minimum, it is the low as compared to the CP's observations. The hybrid method greatly enhanced the AV. Accuracy for the Tmax and T minimum predictions decrease with the longer lead times, but hybrid and ANN methods reduce the errors. Hybrid methods excelling and especially for the longer lead time. The most of the categorical skill scores also higher on the hybrid method, but and also I can observe for the skills are more for the monthly scale as compared to the weekly, because the most categorical skill score it is increasing with the length of the scale. Hybrid method significant improvement across all forecast time scales can be observed for the week 1, week 2, week 3 to 4 and monthly scale, with including all training periods. The training period impact is very minimal. Hybrid method is demonstrated consistent predictive proficiency of the rainfall and temperature exchange, regardless of the training period length, and beneficial in real world scenarios with limited data and reduce the computational costs. Thank you. Very much welcome to if any questions.
Thank you very much for sharing your work, Dr. Malasala. We truly appreciate it, and you packed a lot in that past hour. So now we are on to our Q&A portion of the seminar. I'd like to direct everyone's attention to the QR code on your screen. Please enter your questions that you might have for your speaker. And while you are doing that for our speaker, while you're doing that, we'd like to invite you to attend our next seminar on Monday, June 17th, 2024 at 11 a.m. Mountain Time, where we will have Dr. Ben Trabbing, CPAESS Associate Scientist at the National Hurricane Center, speaking on our forecasts of the tropical cyclone radius of maximum wind skillful. Please join us for that talk. And we also invite you to find this talk and all of our other past talks on CPAESS's YouTube channel. And it does look like we have a question here. The person says, thank you for sharing, says, thank you for sharing your work. What future approaches would you like to take to continue your research even further?
Yeah, I am looking for the other activation functions like Rayleigh unit. I am doing a lot of exercise on that. But some problem it is there. I am thinking to how to resolving the issue. Lot of risk it is there. The skill is not consistent. It is improving the correlation coefficient and other skill scores. But when you are particularly going to see for the atmosphere reverse, it is the continuity, some persistency it is required, but that is not there. And the patterns how to improve by using that. As compared to this method, the correlation coefficient incremented is more in the Rayleigh method. But yeah, I'm doing in that way, using some other methods to see the further improvement.
Excellent. So I'm going to keep my eye on the questions in case any pop up, because then we'll interrupt the conclusion. But I would just like to thank you all for coming to UCAR-CPAESS Discovery Seminar and remind you to go to our website to find out about future talks at cpaess.ucar.edu. And here you will also be able to find a link to this talk after it's been uploaded onto YouTube. Dr. Malasala, our sincere thanks to you for sharing your important work with us. Yeah, this work is becoming increasingly important as our climate continues to change and present new health challenges for society. And I know that your work is then applied to, you know, health and water and agriculture. So it's very important. We would also like to, go ahead.
Yeah, thank you so much, particularly for my team and Vijay and the NCEP, now NCEP EMC to support more support every time to come with these outcomes. Yeah.
Yes. Thank you also to Jesse Webb of UCAR Multimedia Services for his invaluable assistance. And I hope that we get to see you all soon at our next CPAESS Discovery Seminar on Monday, June 17th. And thank you and a good afternoon to everyone.